Hi friends, welcome to codewithsugi YouTube channel. In the previous video, we have discussed about most of the operators, but we haven't discussed about bitwise operator. Okay, so in this video, we're going to discuss about bitwise operators. Before we get into this video, if you are new to our channel and if you are not aware of what we have discussed till date, so you don't need to worry. We always used to add all the links in the description. So please go ahead and have a look on the previous videos. We already discussed what are all we have in the bitwise operators. We have and then we have or, and then we have exclusive or, and then we have complement. Okay, and then we have left shift operator, and then we have right shift operator. So before we get into these operators, first I will show you some table to understand this and or operators. Let's we consider two values a and b. The bitwise operator, in the sense it will operate on the bits. Okay, so that means we should have a binary value, then in that binary value it will operate on the bit. If we consider a binary value, then we will have two values, right? Zeros and one. Say for example, let's we consider two values, then we will get a combination like 0 0. This is one possible combination, and another one is a may be 1 and b may be 0. Then a may be 0, then b may be 1, then both are 1. If we have a values like this, then what is the output we will get for and? And means a and b both should have a same value. Say for example, if a is having 1 and b is having 1, then it will return 1. Else in other all cases it will return 0 only. Say for example, a and b are 0, then it will return as 0. A is 1 but b is 0, then it will return as 0. A as 0, B as 1, it will return as 0. A as 1, B as 1, so it will return as 1. The next one is R. So this R condition will be denoted with help of pipe symbol. So in this case, any one, okay, if any one is having 1, then it will return 1. So now we have 0 0. Obviously it will return as 0. Here 1 0, it will return as 1. Here 0 1, it will return as 1. 1 1, obviously it will return as 1. So whenever you perform OR operation, then if any one of the value is having 1, then it will return 1. Okay, then exclusive OR. So exclusive OR, in the sense it is directly opposite to OR. That means if any one is having 1, then it will return 1. Else for all other cases it will return 0. Say for example, a and b 0, then obviously we will get 0. Then a is 1, b is 0, right? Any 1 is 1, so it's returning 1. Here a is 0, b is 1. Here also any 1 is 1, so it's returning 1. Here only 1. Okay, you should have only 1, then only it will return 1. Else if you have 1 1, here you are not satisfying with only 1, right? So because both are having 1, so at this point it will return 0 only. Okay, so this is the exclusive OR. Then complement. Okay, complement will act on only one bit. Say for example, if you have 0, then it will return 1. If you have 1, it will return 0. So now I think you have some good idea about how this AND, OR, XOR and the complements are working. We have two more operators in this. Let's we discuss about that. Now we will discuss about left shift operator. I'm going to take a value 10. So this 10 is a decimal value, right? This left shift operator is one type of bitwise operator, so it will work on the bits. So we have to convert this into a binary to see the bits, right? Okay, to convert 10 to a binary value. Okay, we already discussed how to convert a decimal to a binary in the data type section. So if you are not aware of how to convert that, please go ahead and have a look on that video. Anyway, I will try to cover it here. Now I'm going to take 8 bits. It will start from 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Okay, so we need to represent 10, right? So this value is 1, this value is 2, this is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. Now we have to achieve 10. So 10, 8 plus 2 is 10, right? So this 8 plus 2 is 10, right? So in this place you have to put 1, right? So other than that we have to say 0. Now we got a binary value for 10. Now I'm going to write these values here: 0, 0, 0, 0, 1, 0, 1, 0. Okay, let's we consider we have this 8 bits like this. Okay, fine. Let's we consider we're going to do a left shift operation. If you want to do a left shift on A, then you have to first specify the variable, then you have to specify this operator, then you have to specify the number of positions. Okay, say for example, now I'm saying 1 position. Okay, this one is the variable and this one is the number of position. So to explain it in a better way, I'm going to take one more box like that. We all know this is most significant bit, this is least significant bit. So if you are doing left shift, then based on these positions the bit will get one shift to the left. Let's say consider we have 0, 0, 0, 0, 1, 0, 1, 0, right? Fine. So if we say left shift with one position, okay, then this bit will get one left shift. Okay, that means it will go this side, and if it is going this side means then this will get discarded, right? Whenever we are moving this shift right, the most significant bit will get discarded, then one new bit with 0 will get added here. So if it is discarded here, then this is the our new value. So I'm going to write the new value here. So the new value will be 0, 0, 0, 1, 0, 1, 0, 0, right? And this is 2 power 0, this is 2 power 1, this is 2 power 2, this is 2 power 3, this is 2 power 4, this is 2 power 5, this is 2 power 6, this is 2 power 7. Okay, and here this is 1, 2, 4, 8, 16, 32, then 64, this is 128. Okay, now let's we add the values wherever we have 1. Okay, we have 1 in 16 and then 4. Okay, so 16 plus 4 equal to 20, right? Okay, so if you perform one position left shift operator on 10, then you will get the output as 20. So here you have to understand, like whenever you do a left shift operation, then the value will get double. So if I say 2, then what will happen? Then it will shift 2 bits. Okay, then this bit will go away, right? Then a new bit will added here with 0. Now what will be the output? Say for example, here you will have 1, then this will be 2, this will be 4, this will be 8, this will be 16, this will be 32, this will be 64, this will be 128. Okay, now you have to add wherever you have 1, right? So that will be 32 and then 8. Okay, the remaining are zeros, right? Then 32 plus 8 equal to 40. This how this left shift operator will work. Okay, so based on the number of positions you will get the output. So we saw one example with 10, right? If you perform left shift operations with one position, then you will get 20. In that same way, if you perform 2 position left shift operation, then you will get the output as 40. For the one shift you got output as 20. Okay, initially you had 10, then you got 10, 20. Then one more time if you do one position shift, then this value get double, so 40. So here you have to understand, like whenever you do a left shift operation, then the value will get doubled. Okay, that is the one thing you have to understand it here. So we have discussed about left shift operation. Now we going to discuss about right shift. Okay, so the right shift will be denoted using double greater than symbol like this. Okay, so here I'm going to take a equal to 10. For easy understanding, I'm taking 10. We all know, right? The binary value for 10 is 0, 0, 0, 0, 1, 0, 1, 0. Okay, so I'm going to write it here. So in the left shift operation, one bit is moved to left side, right? But in right shift operation, here one bit will move to the right side. Okay, after the movement, the value will be replaced with 0. So say for example, if you perform a one position, here this is the variable and this is the number of positions. So for example, on 10, if you perform one position right shift operation, then what is the output we going to get? Let's see it here. Now we need to move this one bit right side. Okay, this is LSB, this is MSB, right? Okay, here I will say it MSB and LS. I will write it here 0, 1, 0, 1, 0, 0, 0, 0. So in this example, we going to do one position right shift. Okay, if you are doing one position right shift, then obviously this value will get discarded. Okay, then in the most significant bit you will get 0. So now this is the new value you are getting after one shift right. Okay, fine. So the new value will be 0, 0, 0, 0, 0, 1, 0, 1. Okay, so this we can say 2 power 0, 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. And we all know the values, right? 1, 2, 4, 8, 16, 32, 64, 128. Now we have to add the values wherever we have 1. So here we have 1 and here we have 1. So other than that, everything will be 0, right? So 4 plus 1 is 5. So if you do one position right, then that value will be divided by 2. Okay, that is what you got it here, right? So 10 is the original value, but after one shift right, you are getting 5. Then what it means, technically it is divided by 2. Okay, so if you do a left shift with one position, the value will be multiplied by 2. Okay, then you got 20. The same way, if you do right shift with one position, then the value will be divided by 2. So this is the main thing you need to understand from this left shift and right shift operations. Okay, I think we have clearly discussed about how this left shift and right shift operators are working in the bitwise operator. I think we have discussed clearly about what is meant by bitwise operator, okay, and how this bitwise operator is working. All those things we have discussed clearly. Still, if you guys having any doubts in this bitwise operators, then please feel free to put your comments in the comment section so that we will try to have a look and we will revert back to you as soon as possible. Thanks for watching our videos. Please subscribe our channel for more videos like this. Keep supporting us. Thank you.